Hello Internet, in this video we are going to be looking at Java Streams. So Java Streams is an API introduced in Java 8 that kind of allows you to do some LINQ-like stuff in Java. So the last video we did on Java, we looked at the reactive extensions, and streams are similar to that. They can do a lot of the same things, but they're not as extensive. So with streams, you can kind of manipulate data that you have. If you have a list, you can iterate over that and do some filters and stuff on it, or sorts or whatever. But you can't like watch it in real time, not easily at least. It's usually designed for something that you execute once, whereas the reactive extensions, you can actually kind of react to things in real time. So the use cases are a little bit different, but a lot of the functionality is the same. So we're going to be using IntelliJ and Java 8, and I just kind of wanted to kind of show some demonstrations of what this can do, because at least for me, I didn't know about this until somebody showed it to me, and I thought it was really cool. There's some restrictions to it. It's not as extensive as say C#'s LINQ stuff. There's just Java language restrictions that don't allow that to happen. There's no extension methods, for example. And generic types are really limiting in Java. Java uses what's called erasure, which means after compilation, all of your generic types are just objects. And that means when you lose that type information, there's a lot of stuff you can't really do. And that kind of gets in the way. But anyway, let's say I want to create a stream of numbers. So I can do something like that. And that just creates a list. It's similar to a list. It's just a stream set of data that will be lazily evaluated. So none of these functions that I'm typing will be evaluated until I close it, until it's a terminating symbol, I think is what they call it. But let's say I want to filter all of those values. Just say where the value is greater than or equal to 3. So this should return 3, 4, and 5. So if I do that, then I can, for each of those, for everything that's in this sequence now, let's say I want to just print them. So let's do that. And so that's not going to work. We're going to need our value there. So this is super simple, right? But what it should do is hopefully print 3, 4, 5. Once it compiles, it's taking its time. There we go, 3, 4, 5. And so this is sort of a demonstration of we're building a stream, then we're filtering it using just this filter, then we are just iterating over everything, so for each. If we want to multiply or change this a little bit, I can stick like a map. And so this is similar to the select statement in LINQ. And what this is going to do is it's going to map stuff onto something else. So if you're writing like a MapReduce function, this can do that. In our case, we're just going to square the value. So value times value. So now we should see 9, 16, and 25. So if I rerun that again, it should go faster, and we do. So effectively what this is doing is same thing. We're filtering values out, and then we're mapping them, which is a translation function. It's a way of changing some input into some other output that is based on that input. And then we're just looping over it again. So we can do a lot of this kind of stuff. But the cool thing is this works with other stuff. So if I can remember how to build a int array, let's just make a set of numbers. So numbers equals a new int array of 1, 2, 3, 4, and 5. Okay, good, that does work. a little bit cautious there, but I don't think I've ever actually tried that. But anyway, let's do that, and then let's actually create one. So what you'll notice is there is no way to do like an of. If I do of numbers, that doesn't actually work because what I've done is created a stream of int arrays. So this entire thing is just one object in this stream. That's not what we want. We want each of them to be separate. And you'll see there's no good way to actually get there from here. There's an of that we can use. We can iterate over something. We can generate something, which will allow us to actually create like an infinite list. We'll get to that before the end of this. But there's nothing there that can actually get you what you need. And there also isn't anything on the array that can get you this stream. But what you can do is there is an arrays stream. So we're going to create a int stream. So going back to that weird Java is weird thing, some of these functions only work for certain types. So for example, since we're using ints, that will expose, since this is not a stream, it's an extension of a stream, it's an int stream, we can do something like sum. And this sum will return it'll be a completed set, but it will take the sum of this. So if I get rid of this map, for example, this is going to sum 3 plus 4 plus 5. And it's going to be built out of that array. So if I run this, we should get 12. If I was smart and actually printed it. So if I print this out, we should see 12 show up. And that's just a sum of this. That doesn't work if you just do an object. Like, what's a good way to demonstrate that? So there's an object array, for example. If I create an object array, this doesn't really matter what it is. Create new object array. This is totally for example purposes, but this won't have the same thing. So if I do that arrays stream, well, first off, I can show you what I'm talking about. So there's all of these different streams, and notice the return types are different. So ints, longs, and doubles have their own separate streams, which include some of these extra functions. So you can do certain things with double streams that you can't do with just a normal stream. And summing is one of them. But if I just create that stream of objects, you'll see there's no way to sum it. But you can actually create a sum of it if you want to. That's done using what's called a collector. And so a collector, actually, there's multiple ways. There's a reduce, which will reduce a function. It'll take some function and apply it to whatever the mapping is. And you can use that to actually compress the thing. If you want to say, take your stream, which only really works for streams. If your API doesn't support streams, and most streams are designed to be iterated over once, if you want to actually take something out of that, for example, there's a to array, there's a to nothing. So like I can create a array out of this. But if I want to build a list, you can actually see it's suggesting some of those things. So if I want to build a list or create a set or a collection or something like that, if I want to collect things, the way you do that is you use a collector. So the collector will actually be a set of a number of ways of actually collecting things. The easiest way to do this is to use the deep built-in collectors helper class. And this will allow you to like group things or join things or take the minimum of some value or any other thing. You can see there's a number of these here. And all of these are pre-existing. So if I want to make a list, for example, what I've done is in a very complicated way, not necessarily the most efficient way, but I have created a new list from this object array. So I've taken this object array, thrown it into a stream, and then got a list out of it. This obviously is a simplification of that. You wouldn't do this in real life, but if you want to say filter something, So let's say if I take a stream of our numbers and I want to filter it so that our number is divided by 2 is equal to 0. So our number would be even. So I only want the even numbers, and I want them sorted. So I want a sorted list of even numbers from a random. I've got to actually make this random, or this is going to be a really crappy example. Let's do 2 and 6, and then 7, 10, 9, 8. Sure. So that's, yeah, some random set of values. We'll throw a 0 in there just for fun. So now I should be able to take this, throw this into a stream, filter out everything but the evens. So we get only the even numbers. We sort them. So it's sorted. One thing to note, this sorted is going to be a stable sort as long as you're taking a sorted stream. And we haven't really talked about sort or stable sorts versus unstable sorts. Effectively what that means is if you have two values with the same key for what you're sorting on, say you're sorting by last name, and there's two people with the same last name. If you're doing that, a stable sort will make sure that the two people with the last names in that sort stay in the same order as was passed to that. Whereas if it's an unstable sort, they may get flipped around. And so by doing that, by making a stable sort, you can actually theoretically stack these things. There's two ways to use this sorted. There's the way I'm using it, which is just saying sort this list, which I think expects it to be comparable. Alternatively, if we want to actually select something, I believe you have to give it a comparator, so this isn't going to work. Comparator or something. You'd have to implement it. We don't need to do that. It should be fine for now. It really isn't going to like this, is it? What don't you want? Supplier. Oh, it's expecting me to do something like shoot. Integer list. I'm doing this wrong. One sec. This is not correct. I don't even need this. We can just throw it. Well, no. Sorry. Totally getting distracted. We can actually just print this. There's no reason we can't just throw this out to something. So I'm going to print out the value. We're actually going to need to save that somewhere. So pass that in like so. And now our filter comes in, sorts everything, and then prints it. So theoretically, we should see a sorted list in this. Yeah. So we get 0, 2, 4, 6, 8, 10, which is what we wanted. So that's sort of a really simple way of doing that. If we want to get even more complicated, we can do something weird. Like let's say in Java we want to create a array that is initialized to some default value that isn't the default value of whatever it is you want to take. There's no good way to do that except writing like a for loop. So if I want to say create a set of negative ints, if I do a new array of say 10, this will all be defaulted to 0 because 0 is the default int value. But what if I want to initialize everything to be -1? If you want to do that, you are going to do something like, not that. You're going to create a stream and actually use something like this generator. So this generator is going to take something. I want to return -1. I don't even think we need that there. There we go. So I want to just say for everything, make it -1. So just plug in -1 every time I ask for a value. And then I want to take, it's not called take, is it? It's called limit. There we go. So effectively what I'm doing is I'm doing a pagination of our data. I created an infinite list of -1s. Now what I want to do is take 10 of them. So I'm just taking 10 elements from the front of that list. And you can use this for anything. Like if you have, say, a very long list of videos or like tweets or something, and you only want to take a limited number of them, you can use limit to kind of introduce pagination. And you can actually, I think there's a skip too. So with a combination of skip and limit, you can actually implement pagination pretty easily. So we've got our limit here. We're taking 10, and now I want to create an array of stuff. So this effectively just kicks out an array of integers, which works. There's nothing wrong with this. But what if I'm not using an integer, for example? This works because the integer automatically supports toArray. But what if I had like objects? So what if this was not producing integers? What if it was producing a new object? I'm going to take 10 of those, produce, that actually would work, but anyway, the way what I'm trying to get to is you can actually do this. And so this is sort of the shorthand for actually creating a list of things. A good example might be, let's just create a really quick class here. Public class test, and I'll give it some generic type. Everything else doesn't really matter. But if I want to do this with that, so I want to create a test of objects. So we can create a new public static, there we go. So we expose our class. I want to create a new test object there. I can do this, but I don't think, I was running into this, but this usually throws some sort of weird exception, especially if you do generic types. So like a list of objects. Okay, never mind. Seems fine. Ignore that. But anyway, keep in mind, if you want to output something, like here we have a toArray. If I want to just grab this object, I can do test array, so create a test array, and just wrap that new constructor there. Wrap the constructor in this syntax, which will just say, use the new function, use the constructor to build this. And so if you have other functions that would help with generating this, you can use that too. So this generator now has random objects in it because I just created those. Let's revert that to -1. So now we have a set of negative integers. That's not going to work. There we go. So I have 10 negative integers. Let's drop this array. Mostly, well, I guess let's actually store the array. That'll work. That will work. So Java has some weird things with the types. Ints and integers are different. In C# they would be int and int32. Those kind of work the same in C#. In Java, they're different. The best example I can give you is integer is almost always going to be a reference type, where int is a value type, which is weird until you realize that you can do something like this, say value equals null, and that works. But if I do this, that doesn't make any sense, and Java is going to get really angry at me because null isn't an integer value, but it can be. There can be a null reference that works. So that's the difference, and that's why it's yelling at me. The important thing is that you can't use int or double, or any of the other primitive types, those don't work in as generic arguments. So you need to use these full names, otherwise it doesn't work. Cool thing is Java can, for the most part, translate between them. So you get an int out if you plug in an integer, but it's a little bit different. It's kind of a funky little type. But anyway, we now have these integers here. Let's loop over them. So for each integer I in our negative integers. So this should print just 10. Oops, print line 10. It should print 10 negative ones effectively, which is kind of boring, but it kind of gets the idea across that you can kind of initialize this array to something. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And you get 10. Which in this example, it's not super exciting. It's not crazy. But I think it's cool because it gives you that option of initializing that array to something that it wouldn't have been previously. And so that's kind of cool. But for the most part, I just kind of wanted to explore this thing a little bit and kind of introduce the idea of streams, because I think it's a nice way to write things, because initially you look at it and you're kind of like, I don't get this. But after you kind of start working with it, it feels a little bit more natural, I guess. You're kind of saying, here is my data. Here's what I want to do with it in these steps. And then what do I do with the result? And so it's kind of a very procedural way of kind of going through it. And the way you write it is a little bit simpler than doing a bunch of these for loops. Like we could just write a for each for that, and it would work. Like this normally would take quite a bit of code, mostly because you'd have to like write this filter to pull things out. But you can't pull things out in a for each loop, because then that breaks the for each, it breaks the iterator. So then you have to come up with custom logic for that. And then the sort, you kind of have to work out, and it just gets a little bit funky. So this kind of clears a lot of that up, and you can get pretty complex stuff on a single line. So yeah, I don't know. I think it's cool. I guess I'm curious what you guys think. So if you've got feedback or think it's cool, or you're like, I would never use that, let me know in the comments, and I don't know, maybe we can start talking about it. But yeah, that's it for this video. If there's anything else you guys want to see, any other ideas you have, projects you have ideas for, whatever, let me know. I'd love to hear it. And if there's any feedback you have for me, anything you want me to improve or change or do better, I'd like to hear that as well. Some announcements. One, I did create a Discord channel. Some people have been asking for that. So I've actually spun that up. There's a link to it in the channel description. And I've started throwing them in the descriptions for each video as well. It's right at the bottom of the description. So it's a public thing. I don't really know how it's going to go. It's kind of empty right now. I have a few friends and we kind of play games on it. So if you guys want to join in like League of Legends or whatever, we can do that. Or if you have questions, we can answer those. Some of the open source things like Unity Shell, we're kind of talking about where to go with that. So if you guys want to be a part of that or just kind of hang out, go for it. But yeah, that exists. Also, videos are going to be sparse the next 2-ish weeks. I've got a lot just to do outside of this. That's going to take up a lot of time. I'm trying to schedule things so that I can actually deliver somewhat consistent content, but it's going to be busy. So we'll see what happens. What else? That's about it. So yeah, that's it for this video. If there's anything else you guys want to see, if you like this Java stuff, or you want me to do more C# stuff, or you want me to try something else like Go or Python or I don't know, JavaScript, let me know. and we can certainly look into that. So yeah, until next time, it's the internet.